All right. Yes, go ahead. Sorry? Is it locked? Let's see. Sometimes I forget to release it. Even this one? Oh, yeah, it is. You're right. Okay, I have to publish it. That's why. Okay, so let's see. How do I do that? Okay. It's marking it as private. That's why.
Yeah, you don't have to do it.
Manager, maybe. And it's 0302. This one here, publish. There we go. Okay, now you should be able to see it. Okay, thank you. That's a good catch. Good catch. All right. So I'm gonna get started when you guys are ready. Okay. All right. So we do have an active homework assignment, and I'm not sure where you guys are at this point. Are there any questions about the homework assignment?
The find factor, yes.
Mm-hmm. Any questions about it? You guys get a general idea? Yep. Mm-hmm.
I have a question.
Yeah, go ahead.
So, I had to get some help with the homework, but what I was having a little trouble with was just the variables. It's kind of confusing if you don't write it out. Can you maybe explain the variables that are available to us?
The variables, you can declare additional variables if you want to, but there should not be any need for it. Now, your solution doesn't have to be the optimal solution. In other words, if you have to declare some additional variables to get it done, it's not a problem. Okay, I'm not going to take any points off if you need to declare any additional variables. So is your question about how to declare additional variables, or is it about how to use, or how do we figure out whether we need additional variables or not?
Just the available variables that you gave us.
Okay, so we'll take a quick look at the code, and I think that is still in control structure. Yep, pretty sure about that one. Okay. And the homework assignment is find factor. Okay, so there are two. Okay, are you guys ready? Okay, come on. Okay, ready? Okay. So you have basically two, quote-unquote, two variables already available to you, and that's all you need, really. The first one is the parameter itself, which is x. This is initialized, or the value comes from the invocation, the caller. And then the other one is factor, which is a local variable inside the subroutine find factor. And this is also the one that you're going to return. Okay. So if you remember the spreadsheet that we did last time, the spreadsheet, there is one column for the factor, okay, the potential factor, and then we have another column to determine whether it has, if you divide x by factor, do we have a remainder? That's what the other two columns are about. So that means, you don't need any additional variables because, what you have, because the other two columns in the spreadsheet are dependent on the number itself, which is x here, and also the factor. So from these two variables, you should have enough variables to work with to get this done.
Are both of these variables considered local?
In a way, yes. Because this is a parameter, and a parameter is kind of like a local variable with only one difference. The value of x is determined by whoever is calling it. So in this case, we have line 12 here that is calling find factor, and as a result, 26 is going to become the value of parameter x when it is called. But factor, on the other hand, is a local variable, which means it does not get any particular value from the caller. In fact, it does not have any particular value until you initialize it inside the subroutine. So you got to remember to initialize a local variable, not a parameter, before you make use of it. The warn all will probably warn you about it, if you don't initialize before you use it. Okay, so that's a good catch, from the compiler. All right. Okay, excellent. Any other questions regarding this homework assignment? Yep.
So we wanted to return a number like 13, for instance, be successful.
Yes, but in this case, if you return 13, you're going to skip 2, right? Because the first prime factor of 26 is 2. So to return 13 means you have an algorithm that does not scan from low or small prime numbers to larger prime numbers. Okay. And I think it is easier, to go from 2, 3, 4, 5, and so on, kind of like the spreadsheet last time that we did. Okay. All right. Any other questions regarding the homework assignment? It is due next Monday. Okay, so you have another 5 days or so to work on it. Any other questions? If there are no additional questions about the homework assignment, we are going to continue our discussion for, with file operations. So I'm going to skip all the way to file operations, or input and output using files. And I am intentionally skipping global variables because I just don't want to talk about it until we need to use global variables. All right. So we talked about, what is a file already, okay? What we think of a file normally in an operating system class is not really quite how we look at a file in this class. Do you guys still remember what I used as an analogy of a file in this class? A conveyor belt, exactly, okay? So your program has, several conveyor belts, one coming in and several going out, that are always available to your program already, okay? Standard input file is the one single conveyor belt going into your program, and standard output file is one of the 3 standard files that are going out, okay? But in this class, we'll just go ahead and use that one single one for the time being at least, okay? We talked about the classic Hello World program, which is this one here. I'm just going to open a new tab, which should not come as a big surprise. So what we'll do today is to take a look at this program again, but this time we'll take a much more detailed and look at this program, kind of more slowly today. The first line, if you have read the notes, this is nothing new. The first line is a pound include, but pound include is not considered a statement. It is considered a preprocessor directive, okay, or macro, if you will. What it does is it will locate a file actually named stdio.h, but it is not in your folder. It is in the system folder somewhere else, and it will include the entire content of that particular text file as if it is a part of this particular program. It does not bring in the definition of printf. What it does is it brings in the prototype of printf, okay? And I'll explain what a prototype is later on. But that is needed because without this line, without line 1, okay, without the pound include line, the C compiler will encounter the printf on line 5, and then it will say, hey, nobody told me anything about printf or how to use printf. And then the compiler will complain and say, I don't know how to use printf. You better make sure that you tell me how to use printf first. And that's the whole purpose of a prototype of a function, is to tell the compiler, hey, in order to use this function, you have to supply this argument of this type, this argument of this type, and so on, or the number of arguments in this case. Are there any questions about what line 1 is doing in this program? It's including what we call a header file. And the header file includes the prototype definition, not the actual function definition. The other parts would be the use of double quote. Okay, the use of double quote is used to delimit a string in this case. So hello world !! \n, which is the line feed character, is considered a string in C and C++. And that's just exactly how it's going to be printed in this particular case. Any other questions about this program? No other questions? What about, how do I find out how to use printf? Okay, because we are all using the virtual machine, so that means you all have access to this particular document. And When you use the man page, you can use a -k, which means I'm looking for all man pages that contains the keyword printf. That's what the -k means. So this is a quick way to locate what kind of topics is available, and it relates to printf. And you can see there's a whole bunch here. Out of this whole bunch, only 1 or 2 is really related. And you can see that printf is here, 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 and here. This you don't have to worry about because we are not programming the AVR architecture, so you won't find these particular entries here. So you basically only have to worry about the first one and the third one. The difference is the first one is a shell command in using printf, and the third one is the one that we want. Okay, the documentation of the function in C++ called printf. So once we have located this, we can use the man page. So we can use man, which is a command in almost all distributions of Linux. I do not know of one that does not include man as a tool. 3, which is the chapter number, that's coming from the number in parentheses, and then just printf here. So what this does is it will bring up what we call the man page or the manual page of printf. Now a lot of this documentation is complete, but it is kind of terse. Okay, it is assuming that you know something about C++ programming already, but nonetheless, it is still a good way to look up information because it is a very complete documentation. So if you read this, it has a long description because printf has a long history and therefore a long documentation, and it keeps going. It talks about the return value. It talks about the format string itself. And later on, you will find %d. Okay, I will just keep going here until we get to %d. It just keeps going like this. Okay, so the conversion specifier. This is where this is the character after the %. If you specify %d or %i, which are considered the same, it will basically print the number out as an integer. And that's what we're doing with this class. %x, on the other hand, will print the number out as in hexadecimal. O is in octal, and then x, uppercase x, would be in hexadecimal, but use uppercase A, B, C, D, E, F instead of lowercase a, b, c, d, e, f. But this is the documentation. Now when you're done with man, and you want to get out of man, you just type Q on the keyboard, lowercase, and it will get out of the man page. All right? So are there any questions about using the man page, or just finding out what is available in the man page? Any other questions? What about some of the commands that we have been using already, like G++? How do I learn how to use G++? Man G++, right? And oops, I'm not including the documentation for G++ here. What about man itself? You can actually say man. So this is the man page of the man utility program itself, and it tells you everything that you need to know and a whole lot more about how to use the man utility program, the manual program. Okay, so this is a pretty good resource if you want to learn things on your own, okay, or be able to locate the details of stuff that we talk about in class. This is a good way to do it. All the commands that we use, okay, including ls, there's a man page for ls. Okay, if you want to know how to make a new folder, there's a man page for that. So a lot of the commands that we use in this class already have man pages corresponding to them, and that makes it easier to look up, oh, okay, I just want to know how to do this, okay? How do I delete a folder? It's rm, okay? So how do I remove a file? Okay, rm removes files or directories, but you kind of have to know all the extra switches. These are called switches, additional parameters that you pass to rm. Okay. Okay, so kind of enough stuff about. Yep.
So when you want to remove the file, so you just type rm and enter.
And then the file name.
And then it's done.
Yep, yep. So it's just like this. Okay. So I'm going to do ls here. So let's say I want to remove a file called header.h. Okay, that's the file I want to remove. You just say remove rm header.h, and that will remove the file. If you want to remove a folder, on the other hand, it's a little bit more complicated. So if you want to remove a folder, so I'm going to create a new folder here, okay? To be deleted, okay? That's the name of the folder. If you want to remove a folder, you cannot just say rm remove to be deleted because it's a folder. So you have to use rm-r, okay, to recursively delete a folder, just like that. So you have to supply -uppercase R to remove a folder. For those of you who don't want to learn any of this, okay, you can actually use WinSCP, to remotely, do all the file management, so you don't have to learn how to do it in Linux. But eventually, I'm guessing that you still have to learn it if you're on the computer science track. If you're not on the computer science track, this may be the last time you have to deal with it. Until they port all of the other engineering and math tools into Linux. All right, so any other questions about all this stuff here? Just some additional stuff, you don't have to do it, but I just find it might be helpful that you know how to find additional information. Back to this classic Hello World program. Are there any questions about the Hello World program? Okay, nothing. Go ahead.
So if you wanted to do printf, you would have to have the include studio.
Yes, STDIO.
If you wanted to use like a 32-bit integer, would you have to do the include
stdint.h?
You have to do both.
Yes, you can do both. Yep. If you have a pound include and let's say this program, for this particular program, and you don't need to use printf anymore, the pound include doesn't really do anything that's bad. It's just increasing the compile time a little bit, but it's not going to make your program bigger or longer if you have some pound include that is not actually needed. So it's okay to pound include some additional stuff, because usually it does not lead to getting your program larger or in any way affecting the effectiveness of your program. That's a good question. Okay, so are there any additional questions about this sample program? Okay, no questions about this one? All right, so if there are no questions about this one, we'll move on to the other one, which is the C++ way of doing exactly the same thing, okay, which is this one here. Now this one requires a little bit more explanation. Okay, you can type it in and make it work. Okay, so that's not really the point. The first one is on line 1. We don't have iostream.h. Instead, we have just iostream. There's a link here, down here. There's a long history behind this. You can click on this link and read about the long history of why this one does not end with a .h extension. It is not needed for this class. It's just for those who are curious of why do we get rid of the .h extension. You can read that document. But the file called iostream serves exactly the same purpose as stdio.h. Okay, it includes the definitions that you need in order to make use of various things in this particular program, and I'll identify those things later on. Okay, so it's just a header file. Okay, it's the same thing as stdio.h, except this one is intended for C++ programs. This one is interesting. Okay, the line that is starting with using and then using namespace std is actually for convenience purposes. In C and C, well, excuse me, I have to correct myself. In C++, but not in C. Okay, names have namespaces. In other words, you can define your own namespace and then use exactly the same name as some names used in another namespace. For instance, let's say your first name is John. Okay, well, obviously there are other Johns out there in other classes. Okay, so the namespace is basically saying, okay, with the restriction of being in this class, I want to refer to John without having to spell out the last name. So this is basically saying the implicit last name is std. So this way, I can spell out names, and if it is not found as a recognized name by itself, it will automatically, assume a quote-unquote last name of std, which is standard, and say, oh, okay, maybe it is related to the std namespace. For instance, cout is a name. Okay, it is actually the name of a global variable. Okay, called cout, or it's just the output file of a C++ program. And if you do not have line 3 using namespace std, it will complain about this and say, hey, I don't know of any global variable called cout. Okay, and then you will have to qualify the name with std : in order to specify, oh, okay, we are referring to cout in the namespace of std, and that way, you can spell out the whole thing. So I'll go ahead and just write the program without using namespace, and I'll compile it so that you can see the error message coming out of it. Because that's the quickest way to illustrate why we need that. So we'll go ahead and write a program called cout.cpp. When you are writing a C++ program, it has to end with cpp as an extension, or cc, it works as well. So I'm going to include IOStream just like the other one, but I'm not going to say using namespace std and see what happens in this case. The rest of the program will still be the same. So I'm going to cout, I will say cout hello world, and end line here, and just return 0. In other words, this is pretty much the same exact program as this one here, except I do not have line 3, which is the using namespace line. Okay. Save the program, G++ to compile the program, -1 all, which is not really needed in this case, but I'll just go ahead and include it. And you can see the compiler is complaining about it, and it says, okay, so on first of all, it complains about the include file. Okay, not the include file, but the first complaint is an error here. It is on line 5 of the program, and it says, hey, cout was not declared in the scope. In other words, it cannot find the name cout declared by anyone. Okay, it's not a local variable. It is not a global variable. But then it got smart. Okay, the compiler is smart and say, hey, okay, here's a suggestion. Okay. And that's why when you continue reading the error message, it says, note, suggested alternatives. Okay, so the compiler is being super friendly. This was not the case about 10, 15 years ago. The compiler would just say, I don't know about cout, fix it. But now it's trying to be friendly and say, hey, maybe you meant this. Okay, so it's saying, oh, by the way, there is a name called cout defined, but it belongs to the namespace of std. Okay, so one way to fix this program, and same thing with endl, which is end of line. Okay, so one way to fix this program is to qualify with the namespace and then : whenever you refer to cout or end line. Okay, so we'll go ahead and fix the program that way first, just to make sure that it does work, right? So we can now say, oh, I'm not really just referring to cout as a name. I'm referring to cout of the namespace std, standard namespace. And same thing applies here. I'm not referring to endl. I'm referring to endl of the standard namespace. So we put std here with : So we'll go ahead and try to compile the program. Oops. To compile the program again. And this time, it doesn't give me any error messages, because this is all it wants. It just wants me to specify, oh, you want cout and end line, but they're not in the current namespace. Tell me where I'm supposed to find it. That's all. Okay. All right. So you do have an option. You can choose between, say, using namespace std and not having to say std : all over the place, or you can choose to use std : all over the place and not specify using namespace std. So both are going to be okay syntactically. Yep.
So if you use a certain namespace and then you say use a different namespace, can you do that, or is
yes.
there only one namespace? Or?
You can use multiple namespaces. Basically, whenever you say using namespace blah blah blah, it basically means if cout cannot be found in the default namespace, where else am I supposed to try to find that particular name? Now it will work as long as you don't have namespaces that have overlapping names. When you have namespaces with overlapping names, then it depends on, I guess, the priority, or it may even be considered an error because now the compiler cannot say, oh, okay, there are two names, there's one single name in two namespaces, and you are using namespace with both of them, and when they have collision or conflicts, I think the compiler would just complain and say, I don't know which one you're referring to, you have to specify using the : notation.
Can you use a namespace for like a certain part of the code and then change namespaces, or?
I believe so, because you can move that statement inside the scope like this one.
Oh.
So whenever you have an open curly brace and a closed curly brace, it is considered the delimiters of a scope. So if you specify using namespace std here, then the assumption is only going to affect whatever is between the curly braces. Now this is an easy one to test, okay? Because I can now say, let's get rid of the actual : notation in here, and then elsewhere I'm going to do it, with without the : notation and see where they complaints, right? So I'm going to have a little subroutine f that really doesn't do anything useful. It's not even getting called. It's just for testing purposes. All right, so this is a good test, and in fact, I will put this definition after the other one, just so that there's no confusion now, okay? Because namespace is on line 5 and it is before line 10, so we cannot say, oh, but that's before we use the statement using namespace. So we'll go ahead and compile this program, and it does complain about the second one because it is out of the scope where using namespace is located. Right. So did that answer the question? Okay, very good. Yep. Mm-hmm.
So do we have to use std for namespace, or can we use something?
Well, you as I said, you have two options. You can either say using namespace std so that it becomes a default, okay, one of the defaults, or you have to qualify each time you use cout, end line, and so on. Okay. Any other questions? Yep, go ahead.
Just off what I think your question was. So if you did using namespace std globally, you wouldn't have to do it anywhere else.
That is correct. Now, it does potentially lead to problems, okay? Because the idea of using a namespace or having a namespace feature in C++ is so that you can reuse the same name, like a common name like max, okay? Sort, okay? Or compare or something like that. And you can define the same name for a different namespace that has a different meaning. So you can now say, let's say integer : max, or float : max, or something along that line to differentiate between the variants of the same name but in different namespaces. So the moment you start to using namespace, you're kind of defeating the original purpose of having namespaces to begin with. You see what I mean?
Yeah.
Yep. It's kind of like, in this class, so let's say we have only one, I just have to pick a name. Let's say we only have one Pat in this class, okay? Then I can say, oh, by default, if I do not spell out the last name, it is Smith, okay? So when I say Pat and do not spell the last name, then it's by default Pat Smith, okay? So if there is exactly one Pat in this class and it's Pat Smith, then it's working out good, right? Because I don't have to spell out the entire name, first name, and last name. But when I have two Pats in this class, Pat Smith and Pat Green, then it's not going to work. But then I can say, oh, let's use another using namespace. If I don't spell out the last name, then we'll go for a default of Smith and another default of Green. But it won't work in this case because there are two Pats in this class. One is Pat Smith and one is Pat Green. So when I say Pat in the class, both students will raise their hand and go like, okay, what do you want me to do? So that's why the use of a default quote-unquote last name is kind of defeating the whole purpose of having a last name to begin with. But that's philosophical, okay? It's not a language thing. It's just in my opinion, it's not it's defeating the whole purpose of having a namespace. So any other questions? Yep.
What is the less than sign?
Oh, okay. Well, so let's take a look. Okay, so you're referring to the less than here and the less than here. Basically, it is used to specify what do you want to print to see out, which is standard output. Okay. Remember, this program is doing exactly the same thing as the previous program. So the less than symbol is doing is specifying what you want to print. Whatever is on the right hand side of less than in this case is the content that you want to print. Okay. Which is kind of odd because now we are specifying that we want to print end line using a file called hello world, right? Because according to that definition, this is how it should be interpreted. So the way to kind of fix this problem of the interpretation of the less than operator is to say that it is left associative. Okay, let me explain what I mean by left associative versus right associative. So we'll go ahead and fix the program first to make it work again. Okay, so we'll go ahead and go back to cl.cpp, get rid of this so that the program works again. Okay, so we'll go ahead and make sure it works, G++, and then we'll go ahead and link the program. Okay, so the program does work. Okay, it is printing out exactly just hello world with a line feed at the end. Is that okay so far? Okay. Remember what I said a little bit earlier. The less than symbol, which is also the left shift operator, but it is not really doing any left shifting in this case, is left associative. What I mean is it is the same thing as putting parentheses around whatever is on the left-hand side. That's why it's called left associative. If you don't specify any additional parentheses, it is always putting parentheses to the left-hand side. Okay? And if I want to separate hello world into two parts, this is what I should do. Okay? So if I want the first part to only print hello, and then the second part to print world, I can now break it up like this. Okay, I'm just moving the cursor out of the way. This is really saying the same thing as cout less than hello less than comma world exclamation point less than end line. I'm just putting in the extra parentheses to emphasize this is how the compiler interprets the operator when you don't have parentheses. But what is it telling you? What is the value of a particular expression using the less than operator? It has a certain implication now, right? So if you look at, let's say, this operation here, okay, this operator or this expression, what do you think it is actually, what is the value of this expression? What does it have to be to make this work? All right, so the other way to ask this question is, what am I doing to this part of the expression with the rest of the expression? I'm using the less than operator to print this part of the string as if this expression is cout. Is that making any sense? Okay, let me say that one more time. Let's look at the first one first. Okay, so let's look at this expression first. This expression is basically saying cout is a global variable that is representing the standard output file. And then the less than, otherwise known as the left shift operator, is how you specify, okay, so what do you want to print to the standard output file? So in this case, we just want to print the string hello to the standard output file with only the highlighted portion of this code. Is that part okay? Okay, you specify what is the file that I want to output to. The operator is left shift, and then the right-hand side specifies the actual content that you want to print to that file. Is that okay? All right. So if you apply the same reasoning to the larger expression, which is now this part, what is it really doing? Okay, we already understand the left shift operator is going to specify the content that we want to print. But what about the left-hand side of this particular left shift operator. That really is the same thing as cout. So the left shift operator returns or has a value of the left-hand side to begin with. Is that okay? Sort of?
So, what is this gonna print at the end?
Say again?
So what is it gonna print at the end? Is it just gonna print worlds by itself?
Nope. It will first print hello because you have to evaluate the innermost pair of parentheses first, which will print hello. But as an expression, it has two effects now. Remember, when we have certain operators, it can have multiple effects. This is one of those as well. So the first effect of the left shift operator, when you apply the cout, is it will print the content first. But it has a second effect, which is the value of this expression. The highlighted portion here is an expression because it has a left-hand side, it has a right-hand side, it has an operator, which is the left to the quote-unquote left shift operator. So as an expression, it has its own value. Just like 1 plus 4 has a value of 5, this has a value as well. But the value of this expression is kind of special because it is whatever is on the left-hand side of the left shift operator. In this case, is cout. So cout becomes the value of this entire expression. But that's exactly what we want, isn't it? Because we want to look at this entire expression, the highlighted portion, as cout, so that when you apply this particular operator, it will continue to print comma space world to the standard output file. Is that okay? But then when you look at this larger expression, this whole thing is also having a value of cout, which is okay because that's exactly how I want to set it up, because I want to print end of line after hello world exclamation point. Okay? Is that okay so far? Okay? But let's double check and make sure, okay? Because we want to make sure that at least one, this is syntactically correct. Whoops, and the other one. Okay, it is syntactically correct, and the program does behave exactly the same way as before. Now, if the operator by default is left associative, you can change it by putting parentheses and forcing it to be right associative. But that's not going to work. Okay. In other words, okay, I'm just make a copy of this line here and change the program so that I use parentheses to force it to associate on the right hand side and not the left hand side. So I'm going to put parentheses around these two first, and then put parentheses around these two, and you will see that the program does not even compile in this case. Okay. So we'll go ahead and just try it out. The compiler is just going to complain and say, I don't know how to do it, because the left shift operator is not defined for a string type. That's why it just says, hey, I don't know how to do this. Okay, nobody told me how to apply the left shift operator to a string, which is comma world in double quotes. Is that okay? So for the most part, people don't look at the left shift operator with this kind of detail, but I think it might be helpful later on, just so that you remember, oh, everything is an operator, and we somehow have to figure out, is it left associative or right associative? All right, any questions about this? Yep.
So the end line is just being
End of line.
So it's not associated with the exit operator?
End line is it is what we call it's also a global variable, but the definition of end line depends on the platform that you are compiling the program to. So if you're compiling this program in Linux, like what we're doing now, end line is just a single line feed character. If you're compiling the program in a Windows environment, then it will be carriage return and line feed. If you're compiling the program in Mac OS X, it'll be a single carriage return character. And that's why it is nice, because now you don't have to worry about, oh, is it a /n, is it a /n /r, or is it really just a /r, because the compiler, depending on the platform, will choose the right one for you. gonna remove the line that does not work and just get back to this one. So this program is, and I can now remove the additional parentheses because now that we know the implied order of evaluation, there's no need to specify those explicitly anymore. All right. Are there any questions about the use of cout?
This is kind of about the standard output file. Are you going to talk about that in a minute, or?
Cout is representing the standard output file.
So is there one system-wide standard output file, or is that like
no,
per?
That's a very good question. So let me repeat the question just to make sure the recorder catches it. So the question is there a single standard output file for the entire system? Is that correct? The answer is no. There's one standard output file per process. Okay. So now we want to talk about what is a process, okay, which is a very useful concept. A process is a program in execution, an instance of a program in execution. Okay. Now, how is that different from a program? How is a program different from a process? What do you guys think? Yep.
The program is what you write out, and the process is what is actually running.
Mm-hmm. It's an instance of a program in execution. So that implies the same program can be run multiple times in parallel at the same time. Okay? Is that making any sense? Now, just out of what you see right now, do you think there's at least one particular program that is being run right now and it has multiple instances right now? Just looking at the screen right here at this point. And what would that be?
Terminal.
The terminal, exactly. Okay, and also the shell. Okay, the bash. Bash has multiple instances, because when you look at the first one, the first tab of the terminal, whenever you have this interactive prompt, you have a shell running. Okay, because an operating system all by itself cannot interact with you as a person. So in order to be able to interact with you, it has to be running what we call a shell. In this case, called a born again shell. Born, B-O-R-N-E, okay, not the other born again. has no religious connotation, I would just put it that way. Okay, so the born again shell, otherwise known as bash, there's one instance of it running here because I can interact with in this particular terminal. This one has a different bash, different instance of bash running, because if I get out of the editor, hey, I can interact with the system again. Okay, and then this one is yet another one. It is running the recorder, but bash is still running in the background. Okay, bash is the parent process of whatever is doing the recording at this point. Okay, I'm still not convinced that bash is being run multiple times. There are several instances of bash running. Well, one quick way to confirm that is a ps program. So I'm going to run ps-al. Okay, that's printing all the processes in long format. Pipe it to less so that I can go do the page up and page down thing. And it looks kind of messy, okay? But what I want to do is look for the word bash. And you can see bash is now being run. There are 1, 2, 3, 4, 5 instances, at least at this point, and that's it. Okay, so we have 5 instances of bash running. And how do we call an instance of a program in execution? It's called a process. Exactly, it is called a process. So we have 5 processes corresponding to a particular program called bash. And each one, to relate it back to your question, each one has its own standard input file and its own standard output file. But go ahead.
So can one process access the standard output or input of another process?
Nope, cannot. That's one of the things that is kind of private to each process. So they each one has its own input and each one has its own output. Now, when you start up a new process, you can tie the input of one process to the output of another process. That's what pipe is really doing. Okay, it's basically saying, oh, I'll take the output of this process and hook it up to the input of the other process. So whatever you output coming out of a program becomes the input to the other program. Just so that you know a little bit more about Linux, I know this is out of the scope of this class. You see a lot of gibberish here, okay? But out of these 5 bashes, you see 1831, 1832, 34, 35, 36. Okay? So the question now, what is this column indicating? If you go all the way to the first line, is the abbreviation is PID. What do you think PID stands for?
Process ID.
Process ID. Yep. And that's how an operating system can uniquely identify each process or each instance of a program in execution. And I can kill one without the other one, affecting the other one, because I can now say kill a particular process ID, and then I can stop the execution of a particular program in execution without affecting anything else. All right. So that was a good question. I'm glad you asked that question. Okay. All right. So let's go ahead and get out of the mess here. And any other questions related to this particular program? No questions about this one? Right. So if there are no questions about this one, and you really should read the rest here, because that's I wrote it for a reason. And then we are now going to move on, and I think we talked about this already. How do we print a value? Okay, I'm pretty sure we talked about this. And this is the printf way, which to some people is considered the harder way to do things. So whether it's hard or easy, it's all relative, it's all subjective, because if this is the only thing you know, it cannot be hard, right? You just get used to it, and once you get used to it, it's like, hey, I know how to crank out code, easily, okay? And that's where I came from, okay? So to me, this is actually not difficult at all. I know most of these things already. If I don't, I can look it up. So in this case, the format string is this part here, okay? We start with a double quote, we end with a double quote. Everything within the double quotes is the content of a string. So within the content of this string, most things are just printed verbatim. In other words, whatever you specify is whatever is going to be printed. That would be basically everything all the way up to and including this space here. But whenever you use a % symbol, you are telling printf and say, okay, hold on a second here. This is not exactly how I want to print it. I don't want printf to actually print the % symbol with a D after that. That would just be kind of awkward, okay? This is the indication that this is a placeholder, okay? In other words, together, %D is the placeholder to say that, okay, this spot needs to be substituted with the value of an integer in base 10. Okay? But we'll worry about what integer value later on. This is simply saying this is a placeholder. Okay? And the rest of this, from the comma all the way up to this space here, is also printed verbatim because there's nothing special here. So everything's just going to be printed exactly the way it is specified. But then we see another % symbol. And the % symbol followed by an X specifies this is also a placeholder, and whatever that needs to go here is going to be an integer printed in hexadecimal, printed in base 16. Okay? So now we have two placeholders within the format string itself. The first one is %D, the second one is %X. So we have to now supply and say, oh, these are the values that have to go into the placeholders. And that's why we have to specify two integer values after that. This is one expression that has an integer value because I is an integer, and this is the second integer value. The first integer value goes to the first placeholder, and the second integer value goes to the second placeholder. So you have to specify the same number of items as you have placeholders after the format string, and the types have to match as well. So are we doing okay so far with understanding line 7 of this particular program? Are there any questions about line 7 of this code? Yep.
How would you print the % symbol? Just how it is.
Aha. Okay. The % symbol itself can be printed using double %.
Okay.
So % can escape itself. If you have a % following exactly 8%, then it will say, oh, okay, this is not a placeholder. It is just % itself. Okay. And I can double check, make sure that is really the case. So I'm going to say print f.cpp. Okay. And this is what you should be doing too when you read the code or read any type of documentation in programming, is just test it out, right? Okay. This should be just a percent symbol, and then I just say %%. Okay, line feed. Just like that, okay? Simple program, not complex at all. And then we'll use G++. I'll just shortcut the whole thing because it's really simple, okay? That's it. So that's a confirmation, there's a quick confirmation that double percent is it just means a single percent symbol. Yep, go ahead.
How come when we're doing our scripting, we don't need the #include command for like our printf?
You mean in GDB?
Yeah.
Because GDB has its own printf. That's the only reason. So when you go into GDB, it has its own command called printf, which has nothing to do with the function printf in C++. They are related because they use the same format string, the same standard, the same convention, but they are not. One does not lead to the other one, functionally speaking. So when you're in GDB, you can always say printf, %d and comma 5, and it will just print in 5. But in this case, you can also use %x, and then give it a bigger number. It prints it in. I thought it should print it. Yep, there we go. So it prints it in hexadecimal, in lowercase. And this is a really quick and easy way to double check whether your understanding of the placeholders is correct or not. It's just whip out GDB, because GDB is far more interactive than a C program. Okay. That's a good point. Thanks for bringing that up. Yep.
So in the notes, I noticed that the main module,
the main function.
The main function has
a void. It is optional. Okay, if you do not specify void, it is by default understood as void, which means there are no parameters to make. Okay, that's a good point. Yep. All right, so I think we have seen the output of this program already, so there's nothing really new to look at from here. Okay. All right, so now we go to, remember, when you present a program like this, it is for the most part a C program, not a C++ program. The only thing that makes this program a strictly C++ program is how I declare the local variable I. Okay, see how I use int I inside the parentheses of a for loop? That is something that you can only do in C++, but not in C. In C, you will have to move int I, the declaration of the local variable, up here. Okay, so syntactically speaking, it does make a difference whether you are using C++ or just regular C in this case. So what we'll do is I'll present the other way of doing things. What about cout? Can cout be used to print an integer in base 16? And the answer is yes, it can. To some people it's easier. To me it is harder. It is simply a matter of preference, which one you're more used to, and stuff like that. Okay. So in C++, you can just do something like this, and by default, it is printing I in base 10, okay? Because most people want to work with base 10 numbers. So that's the default, okay? And you don't have to understand anything about the format string, the %d, and all kinds of crap like that. You just say, hey, I want to print the value of variable I to standard output, and that's it. So one thing that is important is I is not enclosed in double quotes. Because what happens when you enclose I in double quotes? What is it going to print? The letter I, right? And not the value of variable I. Okay, so if you're interested in the value of a variable, do not enclose it in double quotes. Well, that's kind of easier. So what if you want to print it out in hexadecimal? This is how you do it. So hex is actually a quote-unquote special global variable. So once again, if you do not specify using namespace std, you will have to qualify hex with std : because otherwise it won't be able to find it. So this is basically a flag. Okay, hex is not going to print out in any way. It is simply a flag to tell cout and say, hey, whatever is following here is going to be printed in hexadecimal. Okay, it's just a little flag. It's just a little command to cout and say, from here on, print all integers in base 16. Okay. So to do the same thing as what we did last time or in the previous program, we now have a kind of easier and harder way to do it, because the easier part means you don't have to look up the %d and the %x stuff, because the printf man page is pretty long. Okay, if you're not convinced, we'll go ahead and take a look at how long the man page of printf is. Man3 printf, and I will pipe it to word count. So we are making use of concepts that we have been talking about already, right? Because I just want to find out how long is the man page of printf. I'm not interested in reading the actual content. So I can pipe the output of man3 printf, which is going to be pretty long, and I pipe it to wc, which is word count. So this should tell me it has 515 lines. Now 515 lines does not sound like much if you're reading a novel. But when you're reading man pages, 30 lines can be long already because it's very condensed information. So to read one single sentence will take you a lot more processing than reading a novel. So 515 lines is pretty long. This means you don't have to read that anymore. You just say cout, okay, and then remember whatever you specify in double quote is a string and it will just be printed verbatim the way you specify. So in this case, I space in space blah 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 all the way up to the last space here is just going to be printed verbatim. Dec, DEC, is a flag to tell cout and say, oh, from here on I want to print everything in decimal. And guess what? We have an integer right next to it, and so I, as an integer value, will be printed in decimal. And then we follow that with another string, which is the second part of the literal string, starting with a comma, space, I in hexadecimal is, and then another space. And then we use hex here to specify, hey, from here on we want to print it in hexadecimal. So the next time we have an integer value to print, it is going to be printed in hexadecimal. And then we end everything with end line here. But this approach may seem like it's easy, but I don't like it at all. Okay? And the reason why I do not like this is dec and hex are sticky. In other words, at this point, after this statement, all further integers will be printed to cout will be printed in hexadecimal, not in base 10. So the effect of the base change from decimal to hexadecimal is sticky. It is stuck with cout itself. So if you want to go back to the default of decimal, you have to specify dec again in order to change it back to decimal. And to me, that is just, I don't like things that are sticky. Printf, there's nothing sticky in printf, because every time you want to print something, you have to specify what is the base, what is the representation that you want to use to print it. So there's nothing sticky, nothing to remember at all, because every single time you have to specify again. So that's why I personally like printf a lot more than the other way of doing things. But as a programmer, you have to understand both, because a lot of times you're not working with code that you write. You're writing code, you're maintaining code that somebody else is writing. But here comes the big question, okay? So let's say you get a project, and it is in C++, and it has printf all over the place. And you don't like printf. You disagree with tag, which is fine, okay? And you say, I don't like printf, I like cout a lot better. So now the question is, can I mix printf with cout? Well, that's kind of a trick question, because the answer is yes, you can, but the program may behave in ways that you are not expecting. Okay, it's not going to crash. It is just going to do something that you may not expect. Okay, The reason why that is the case is because printf and cout, they're both what we call buffered. Okay, so that means right after the execution of this statement, it may not do anything yet. It might want to save up, enough output before it actually goes to the standard output file. Go like, okay, here's the stuff. So it may save up maybe 4 kilobytes or even more of content before it dumps to the actual standard output file. Printf is the same way. So that means if you interleave cout and printf, things may not come out in the right order because each one is buffering, so it will only do the actual output when the buffer is full. So you may end up with something that goes like, hey, this is not what I intended. I'll give you an example that almost would work for sure. So for those of you who are kind of thinking, I don't know what you're talking about, this is it. Okay. So I'll just call it mix. And in this one, I'll include stdio.h and also iostream. And we'll just go ahead and write a simple one. Okay, we'll go ahead and declare an integer x. X has a value of 576. And we'll intermix printf and cout in this case. So I'll start with the printf. So printf, the value of x is, without the line feed, because I want a continuation on the same line with the rest. Okay, so this is just the end of printf. And then I use cout to print the actual value, because I don't want to mess around with the placeholder stuff, right? So I'm going to say cout decimal x, just to be sure this is going to be printed in decimal, but without the end of line, because I got something else to say. Okay. The value of x is a particular number, and that's end. And oh, okay, we can do it even this way. Okay, so we'll specify the end of the string, and then we use cout to actually finish up, because I like to use end L. Okay, so the first thing is this program is not even going to compile. Can anyone tell me why this is not going to compile? The compiler will complain about certain things here.
Namespace.
Namespace, very good, because cout, dec, and endline, they all belong to the standard namespace. And since I did not have using namespace std, it's going to complain. So this is what I mean by, it's kind of tedious sometimes because you have to type std : all over the place. Okay. All right.
So all of this std should come with two dot like that.
Where?
The std.
std. Which line?
Yeah.
Which line are you talking about?
No.
Okay. Yeah, so you need to qualify, all those names with the standard namespace, which is std : otherwise the compiler will complain about it. Okay, so let's go ahead and make this program run, and I'm not going to do all the other stuff. I'm just going to do -o in this case. It does work out correctly. Okay. I'm a little surprised that it does work out correctly. Because those two are supposed to be a buffered output, so it may or may not work out. Alrighty. So I did not prove my point, unfortunately. You can probably do a search online and see whether it is supposed to work out or not. This is what I would do, is to say printf cout same program or something like that. Okay. And Stack Overflow is a really good resource, and there are definitely cases where you can clearly tell that a particular question comes from an exam question or homework assignment. All right, so in this case, possible duplicate. Okay, mixing cout and printf for faster output produces ABC, and the following program produces ACB. What's the problem? Okay, so this is a clear indication that it does not work out in at least this particular environment. So that means it depends a lot on the compiler. It depends also on the library, and there's no guarantee that it's going to work, which is actually the worst type of problem that, well, not worst, but one of the worst type of problems that you can end up with. Okay, because it's platform dependent. It depends on the tool, it depends on the platform, and on the particular platform, it works just fine. But if you move the same code to a different platform using a different compiler, then it doesn't work the same way anymore. Those are one of the worst kind of problems that you can have, because you can do the development on one particular platform using Linux, and you say, oh, this program is working just fine, and then you port it to, let's say, Microsoft, okay, in the Windows, and use a Microsoft compiler and its libraries, and it doesn't work anymore. Okay, as illustrated in this particular example. So the bottom line is, don't count on it. So don't count on printf and cout to work well together. Okay, so if you use cout, stick with cout. If you use printf, stick with printf. Don't try to mix and match the two. Any questions about that particular statement? Okay. And you can always read the answer too. Okay. This question has been asked before and already has an answer. If those answers do not fully address your question, please ask a new question. And you get that a lot with Stack Overflow, because people just post a new question without searching for an existing question that is asking about the same thing. All right, so, and I did talk about that too. So do not mix and match. Okay, even though in this particular case it did not seem to have any problem, you cannot count on it. So that's the problem. All right, moving on. Now, input is a lot more fun than output. So now the question is, I'm going to give you the difficult version first. Okay. So we'll go ahead and look at scanf. Scanf is the counterpart of printf. So I'm just going to read this part here, and then we'll go through some examples. Scanf is the counterpart of printf. Printf means print formatted. Scanf is scan formatted. Scan is kind of like input. Not surprisingly, scanf also uses the same formatting standard as printf. What is different about scanf is what is needed to store the read value into a variable. Instead of getting a value to print, in order for scanf to store a value into a variable, it needs to know where the variable is in order to store a value into it. And this is our first and necessary encounter of the address of operator. Okay, so that's just the text portion of it. So we'll go ahead and write a very simple program and see if we can write a program to read a number into a variable and then print it out. Okay, that's all we want to do. So we'll go ahead and write a program, and this program will change over time, so this is not going to be the final form. So we'll use standard io.h int main, declare a local variable x, which is an integer, and then we have a print statement and say x has a value of %d, x, so return 0. Okay. So at this point, this program is definitely, it doesn't make any sense, because x as a local variable starts with a unknown value, so it can print anything. In this particular case, it's always going to print 0 because of certain things that is happening with the first function of the entire program. But you cannot count on it, okay? It depends, once again, on the compiler, it depends on the libraries, and so on and so forth. So x is really uninitialized. So what I'll do is I'm going to say, oh, let's go ahead and read something into x first, okay? So I want to read an integer in base 10. That's what %d really is representing. This is the format string of scanf. And so most people who are just getting into printf and scanf would just basically say, oh, we'll use this format, okay? We're trying to read from standard input file a base 10 integer and store that into x. Okay? Seems to make sense, right? Except when you run the compiler, it's going to complain. Okay, so we'll go ahead and see why the compiler or what the compiler has to complain about this. G++-1 all-c scanf.cpp. So this time I'm just compiling because it's not even going to finish compiling because it's complaining. It complains about warning, %d expects argument of int asterisk, but argument has the int type. Okay, so now the question is, okay, when you see a message like this, what does it mean? Okay, this is saying scanf is expecting the argument to be an int asterisk, but instead of that, I'm giving it just a regular integer. So now the big question is, what is that asterisk meaning? It means the address of, okay, or pointer of. This is read backwards. So the way you read this part here, which is the type, is it is an address of an integer. Okay? So that means we have a problem because this is supposed to be the address of an integer, and instead we're giving it an integer. Why do you think we need an address of an integer instead of just an integer? I mean, what is the difference between those two?
This one you're calling on the integer, this one you're storing the integer.
Exactly, because we're storing something, right? Okay, so if you're storing something, you need to say, okay, where am I going to store the value? So you need an address to specify where you're going to store a value, and not just, hey, this is 5. Okay, what am I going to do with 5? Okay, it doesn't tell me where I'm going to store it. Okay, so the way to fix this program, and this is the first introduction to pointers or address, so I'm not going to get too deep into the concept of a pointer. I'm just going to say, if you use the ampersand symbol, ampersand x means the address of x. So if you use ampersand, which is also known as which bitwise operator. Quick quiz. It's bitwise and, right? Okay, it's also bitwise and, but it doesn't cause any confusion in this case because as bitwise and, it is a binary operator, which means it has 2 values. As a address of operator, it is a unary operator because it only has 1 value to deal with. Okay, it's just like, which other operator kind of behaves the same way? Which other operator that we use all the time in arithmetic calculations can be used as a binary operator as well as a unary operator? That's a logical operator, and or cannot be used as a unary operator. Which arithmetic operator can be used as unary as well as binary operator? It's the same symbol. Minus, exactly. Okay, minus is the same way, right? Because you can specify x minus y. This is binary, okay? Because you're specifying a value before and a value after. But if you want to take the negation of a number, you can just say negative x. Okay. Now it doesn't mean that you cannot do it this way. It's just that you don't have to do it that way. Okay. So minus can serve as a unary operator to negate a value. So in this case, it's kind of the same thing. If you have an integer x and another integer y, this is a bitwise operator. Okay, x ampersand y is a binary operator. It means bitwise and. On the other hand, if you only specify ampersand and x, as a variable on the right-hand side, it is taking the address of x. This means address of x. Okay. Now with an address, we can do a lot more because now we can say, oh, okay, we now want to store the value of whatever integer value that we have read into x, into the variable x, because I'm giving the subroutine scanf the address of the variable. Is that okay? It might be helpful to also kind of emphasize that all variables reside somewhere within the memory of a computer. Okay, and everything in memory has an address. It's kind of like every place on Earth has a location. Okay, in addition to an address or a name that you call the place, it also has a GPS location. And the GPS location is analogous to the address of a variable. Are we doing okay so far? Okay, yep.
What does the comma do in the?
The comma? The comma is a separator of the arguments to the function. Scanf is just like any other function. Okay, it's printf is a function, main is a function, scanf is scanf, printf, and main, they're all functions. And within a function that has parameters, you use a comma to separate the arguments. And in this case, it's separating the format string, which is quote a double quote %d double quote. That's the first argument. And then the second argument is the address of x, which is where am I supposed to store the value. Okay. This is also a good time to kind of help clarify the content of a variable versus the address of a variable. Okay, how are they different? And also the name of a variable. So let's take a look at all three, and we'll try to come up with an analogy that kind of helps distinguish amongst all three. So we'll go ahead and use mousepad here and talk about the three things that we want to talk about. So one is the name of a variable. So we'll just call that something like x. Okay. Then we'll talk about the value of a variable, and then we'll talk about the address of a variable. Okay, so these three things, they're definitely related, but how are they related? And can we find real life analogies to all of these things? The name of a variable is only useful to the compiler, because without a name, the variables cannot be distinguished. If you have to make use of 4 variables in a program, how do you specify those variables without names? Okay, so the names are only useful to the compiler in order for the compiler to distinguish one variable from all of the other variables. Okay, so I'll just kind of write down here to ID to identify a variable from all others in the compiler for the compiler. What about the value of a variable? The value of a variable is kind of the state of a variable. Okay, it's basically tell me a state that is related to, let's say, me. Okay, something that has to do with this particular instant. My body temperature is a state, right? Because it can change over time. Not a whole lot, because I'm not reptilian, but it does vary, slightly. Okay, my weight can vary. Okay, the percentage of water content in my body can vary, right? My skin color can vary. Okay, the sun is starting to come out, and I can get tan, it can get darker. What I wear today, can change too. Okay, from day to day. Okay, so those are all states of a particular thing, and they can change, from time to time. Okay? So this is basically the state of a variable at a particular time. A particular time. I'm using the abbreviation here. Okay. The address of a variable is where do I find the variable. Okay, that does not change. If you're talking about a particular variable, the content, the value, the state can change all the time, but the address does not. Okay, this is basically where do we find the variable. Okay, its location. How do I get to it? Now, obviously, if you have the address of a variable, you can always find the value of a variable. If you start with the address, you can get to the value, but not the other way around. If you know the value of a variable, it doesn't necessarily tell you where to find it. Does that make any sense? But for the most part, when we're dealing with a program, in statements like this, x ampersand y, other than having to get to the content or the value of x and y, I don't really particularly need to know the address of X or Y. Okay? In other words, the addresses of X and Y do not serve any particular purpose other than just getting to the content. And that's why most of the time we are not interested in the address of a variable. We are mostly interested in the value of a variable. But when you need to store something, you have to know the address. Okay? I'll give you one example. Okay? Let's talk about, let's just say, there's a particular, I'm not sure whether this is a good way to do it. Okay, this is probably better. Because I was about to talk about something that is politically incorrect and I just don't want to go there. So I'm going to change the example to something that is perfectly okay. So let's say you're trying to rescue a person. Okay? So you're doing a search and rescue mission. The name of a variable is basically just an ID of the person that you're searching. It's only useful, for the identification purposes of the rescue team. Okay, so before you know the name of the victim or the person that you're searching for, you may just call that, I don't know. Has anyone worked for ambulances or emergency response team? Okay, how do they ID people? Like if there are several people who need help, is there an internal way for you guys to differentiate one person from the other, not knowing their actual names?
Their ambulatory state?
Yeah.
So there's severe, ambulatory, walking, not walking.
No, but that's a state. That's a description of the state. So let's say there's a car accident, okay, and there are 3 people who are in need of medical help.
Red, green, yellow.
Okay, so those are the internal references so that you can differentiate between the 3 people who need help.
Yeah.
Okay, so very good. So that's the name of a variable. Okay, it is only for the identification purposes of, in this case, the compiler. Okay, which person are we talking about who needs medical help? Okay, so when you just say, if you call on the radio and say, somebody needs to go to Red and perform this particular procedure, that's not going to be very helpful if they don't know where Red is, right? Okay, so that's why the name of a variable is just that. It's just for the compiler. The value of a variable is the state of the person who needs medical help. Okay, is that person breathing? Is that person bleeding? Is that person conscious? Those are the states, and that's why they're kind of equivalent to the value of the variable. It can change from moment to moment. Okay? What about the address of a variable? That's the GPS location of the person who needs help. Okay? So if you radio to another ambulance because you only get space or the person the manpower to only handle 1 out of the 3 people who needs medical help, if you radio to another ambulance or a helicopter, okay, and say we need some additional help with blue, okay, is it going to be helpful? No, because they don't know who you are. Okay, where is blue? Okay, they cannot do any help with just blue needs some help. Is it helpful to say blue is not breathing and blue needs help? Well, you're only stating the state of the person who needs help. That's not going to help the helicopter or the ambulance to get to that person. What do you need in order for the ambulance or the helicopter to get to blue to actually perform the procedure? What do you need? The address or the GPS location. I mean, these days, we can just do a GPS location and say blue is here. Okay. Now, I know with a normal person, they can move, so the actual location is also a variable. But we are talking about people who are in an accident and they cannot move, so that's not changing. Is that working? I mean, is this analogy kind of helping you to differentiate between the name of a variable? It's only useful within the compiler. The value of a variable is the state of a variable, and it can change from time to time. And then the address of a variable is where you find the variable. So when you're dealing with scanf, okay, I know I'm going a little bit over time here, but when you're dealing with scanf, you need to supply the address because it is the same thing as calling on an ambulance or a helicopter to tend to a particular person after a car accident. So the ambulance needs to know where is this particular person. That's why we need the ampersand operator to get the address of a variable. Right? Yep.
Is this our segue into pointers?
We're not going to deal with pointers for a little bit, because I just want to finish the input-output subroutines first. And so for now, we just say scanf requires the ampersand operator when you specify the argument. So we're not going to go too much into pointers, because to really get into pointers, we need to get into arrays and stuff like that as well. All right, so we are running out of time for the lecture. I don't have any particular structured lab activity today, other than helping you guys to get the homework assignment. So we'll take a break, and then we'll be back here in about 10 minutes.